I welcome you all for today's class on projection of planes. The problem which I am going to explain is on square lamina. The problem which I have been explaining is on beta angle problem. So how it is a beta angle problem, I will explain it. So the problem is like this: a square plate of 40 sides rests on HP such that one of its diagonal is inclined at 30° to HP and 45° to VP. Draw its projections. So in the problem, in the previous class also I have explained, divide the conditions. So where the lamina has to be placed, initially where the lamina has to be placed. Here you can see here a 40 side of square lamina rests on HP plane. So on HP plane the square lamina has to be placed. How it has to be placed, we will think of it. Next, what is the surface inclination? So because it is resting on HP plane, the surface inclination will be on with respect to HP plane. So HP plane inclination is 30° to HP, right? So next remaining is what? Line inclination. The diagonal is inclined at an angle of 45° to VP plane. So that would be the line inclination. So these are the three conditions, right? So now is asked with respect to a diagonal. So when we think of diagonal, the square lamina, when we think of square lamina, the line joining from one corner to another corner, opposite corners, will form two diagonal. So for a easy representation, what we do one of the diagonal to be parallel to xy line. So when one of the diagonal is made parallel to xy line, then it will be a corner resting. This is very important. If you make a side inclination, then one of the diagonal will not be parallel to xy line, and that will be very tedious for us to solve the problem. So to make it easy, what we do, we make a diagonal. So the diagonal which I am taken is AC. AC is the diagonal, which diagonal that will be made parallel to xy line. So there it becomes a corner resting. So this is how the first position of a square lamina has to be placed. Next, the problem of first position and second position is same that we discussed for the previous problem. So after positioning the lamina, so name it as A, B, C, D. Project it upwards and name this point as A dash. When we see from this direction, B dash is visible, D dash is hidden. Next, C dash has been represented. So this is the first front view of a square lamina. Next, the surface inclination with respect to 30° to HP, the same line will be represented at an angle of 30°. Next, project the line downwards. So A dash to A, next B dash to B, next D dash to D and C dash to C. So mark the points and join the lines. So you will get the second top view of a lamina when it is been inclined with an angle of 30° with respect to HP. Now the line inclination. So which is the line? In the previous case we solved the with respect to the side. Side was the resting position, but here is speaking with respect to the diagonal is inclined. So which is the diagonal? We have considered AC is the diagonal. So the AC line is been inclined at an angle of 45° to VP. So you can see here the length of this diagonal AC and the diagonal AC of second top view is not this one and the same. So at that condition the beta angle problem exists. So first thing what we have to do is, first we have to draw a line of 45° line and we have to mark the point, mark the diagonal line. So which is the diagonal line? C and A. So I will mark the C and A. Original length of A and C is been marked. So after that I will draw the locus line. Next, from the same C point I will measure the distance C and A and I will cut an arc. I will cut an arc. So this CA representation line is been extended up to the XY line, and the angle which is been obtained, that will become the beta angle problem. That is the beta angle. Right. Next, so we got AC point. So remaining is what? Point D has to be represented. So measure the distance from A and D and cut an arc. Similarly from C and D, cut an arc. Similarly, A and B measure the distance, cut an arc. Next, from C and B measure the distance and cut an arc. So thereby joining all the corner points to get the final top view of a square lamina which has been inclined with respect to HP as well as VP. Next, as usual, extend the line upward. Where is A? A is here, A dash is here. So mark the point A dash. D, D dash. Similarly, B, B dash. C, C dash. That is how you have to mark the points and join the lines to get the final front view of a square lamina. That is how it has to be solved. Okay, now we will learn how to draw it manually. First, initially we have to draw the XY line. And name it as X and Y. Next, we have to represent the VP and HP. So, because we are following the first angle projection, VP plane will be above XY line and HP plane will be below XY line. Now, we have to place the square lamina. How we have to place it? It should be a corner resting. Why it is corner resting? I have explained it earlier. Right. So, now what I do? I will take a reference line. Any length. Okay. And a square lamina of 40 mm side, right? So I will draw a line of length 40 mm and the angle is 45 degree. With respect to median line, it is angle is 45 degree. Okay, that is why you can check it. So the angle is 45 degree. Similarly, I will draw another line at an angle of 40 mm and angle is minus 45 degree. Yes. Next, we require another corner point. So for that, I will go for arc method. So I will take this point as a reference and I will take a length of 40 mm and I will cut an arc on median line. So right. So now I will join the yes. Now I will yes. Now I will get the square lamina which has been resting on one of its corner and the representation of diagonal has been shown. That is how the first representation of a square lamina has to be placed according to this problem. For naming, I will mark this point as A, this is B, C and D. Next, I will use a projection line, extend the line up to XY line from point B, from point D to also it lies on the same line. Similarly, from point C, I will extend the line. Next, the line joining from this corner to this corner will be the front view of a square lamina which has been placed on the HP plane. So for the naming, I will mark this point as A dash and this point as B dash in the bracket, D dash and here I will mark it as C dash. Okay. Why I mark it as D dash in the bracket? Because the point B is visible whereas D is hidden, right? So that is why I mark it as in bracket. So similarly, the surface inclination is 30 degree with respect to HP plane, right? So this line has to be tilted at an angle of 30 degree. So I will measure this distance. What is the distance of this line? So it is 56.57. So I will measure the distance and I will mark it here 56.57 and the angle is 30 degree. Yes. Now the midpoint of this line is at a length of 28.28, right? So I will mark a midpoint of this line. So I will use a arc by center point and cut an arc 28.28 and I will cut an arc. Yes. Now for naming purpose I will mark this point as A dash because already I have mentioned here it is A dash. Similarly, this point will be having 2 points. One is B dash and another one is in the bracket D dash. Next, this point will be C dash. Now, I will extend the line using a projection line. I extend the line from A dash to A. Next, from D dash to D. Next, from B dash to D. Next, from C dash to C. So I got all the corner points. Now I will use the visible line and I will join the points from B to C, C to D, D to A and A to B. Next I will draw a median line here from here to here. Yes. So that should be of thin line. That should be of thin line. Yes. Next, naming. This is A, this is B, this is C and this is D. Next, the final step is what? The beta angle problem, right? Why it is beta angle problem? I already explained it. So, I will show how to draw the beta angle problem now here. And the final position will be changing. So, first thing what I do is I will draw a line. I will draw a line of any length, but the angle is 45 degree because he has given that 45 degree to VP plane, right? So I will mark it as yes. Now I will measure the distance of this diagonal AC. Initial diagonal is 56.57. So what I do, I will cut an arc by placing a point on this 45 degree line. I will measure the distance 56.57 and I will cut an arc. 6, 7. Yes. Now I will measure this distance, this diagonal AC. It is 48.97. Before that I will draw a locus line. Yes. Now what is the distance? 48.99. So once again I will arc by center point. I will cut an arc. Using a compass you can cut an arc of 48.99 and cut it on this locus line. Yes, it is cutting on this particular point. So what I do, I will join this point with respect to this. So next I will extend the line. So I will extend the line up to XY line and I will measure the angle between this XY line and this median line. So it is 55 degrees. So this is the beta angle. This is the beta angle. So in this condition we have marked the point C and A. So I will mark it here. So this is the point C. So this is the point C and this is the point A. So remaining is what? We have to mark point D and B. So from A I will measure the distance. I will measure the distance from A to D. What is the distance? It is 37.42. And from C to D it is 37.42. 37.42. Okay, so I will cut an arc by center point. From point A, I will cut an arc 37.42. Similarly, from point C, 37.42. Yes. Next, similarly, from B to C, what is the distance? What is the distance from B to C? 37.42. Okay, right. Similarly, all the sides are 37.42. So, I will cut an arc from point C, 37.42. Similarly, from point A, I will cut an arc of 37.42. Yes. Now, I will join the points. I will join the points. From point A to here, from here, next from here to here, next from here to here. Yes, that is how the points are joined and it is been named. So this point is what? This is C and A, and this point will become B and this point will become D. Okay, now remaining is what? Remaining is what? Final representation of a front view. So extend the line from D to D dash. Where is D dash? D dash is here. Yes. Next from C to C dash. Okay. So the lines which I have drawn, it should be of projection line. Yes. Next from A to A dash. It is XY lines. From B to B dash. Yes. Now finally I will join the points. From where is A? A is here. A to B, B to C, C to D. Next from D to E. So this is how the final representation of a front view of a square lamina which is been inclined with respect to HP as well as with respect to VP by considering the median inclination. So that is what it has been represented here, and finally I will mark the points. So this is A dash, A dash, B dash, C dash, and this is D dash. Okay. That is how we have to solve the beta angle problem. So finally I will mention this angle 30 degree, right? So this is how it has to be solved. Thank you very much.